the atom. What we're looking at is what the atom is made up of, the subatomic particles. We're going to look at the atom as being the smallest piece of an element. For example, you could be talking about hydrogen, uranium, or some other element, and the atom represents the smallest piece of that element. There are about 88 of the elements that are known. The others are synthetic or only exist as radioactive elements. And we think of a molecule as the smallest piece of a compound. For example, water being made up of an oxygen atom attached to 2 hydrogen atoms. To get an idea of how small an atom might be, if you have 1 milliliter of water, which is less than a teaspoon, it's about 1/4 of a teaspoon of water, it is made up of about this many water molecules. And that's really too big of a number to talk about. 3, 6, 9, 12, 15, 18, 21. That's like 10 to the 21st molecules. Now, the atom itself we think of as, and when I think of an atom, I think sort of as a Nerf ball, something that doesn't have a hard shell, but you can sort of change the shape of it a little bit. But that atom is composed of a nucleus, which is extremely tiny. For example, the nucleus of an atom is about the size of a flea in the center of a baseball stadium. Very small. And in that nucleus, we have the protons, the positive protons, and the neutral neutrons. And in the volume surrounding that, we have the electrons. If you look at the relative masses, an electron, it would take about 2,000 electrons, so 1 proton or 1 neutron mass is concerned. But 1 electron is equal to the charge of 1 proton. You've got 1 minus charge and 1 positive charge that equals 0 when you add them up. So charge-wise, a proton and a neutron are equal but opposite in charge. But the electron is much, much smaller in mass than either the proton or the neutron. For atoms, atoms will have a neutral charge, and they will be a neutral charge because the number of protons will equal the number of electrons. So the positive charge will equal the negative charge to be neutral. Now, we can have ions, and we'll talk about those a little bit later. If we were to look at just the density of the nucleus, extremely high, like a black hole, add that to the entire atom, where most of the electron cloud is empty space, then we have densities that are similar to the densities that we're used to. For example, the density of water or the density of iron. Electron cloud, again, is mostly empty space. We've got tiny electrons, but they fill it because they are moving and because they are attracted to the nucleus. But they are attracted to the nucleus, and the fact that they're moving keeps them from being sucked into the nucleus, since opposite charges attract. But you can think of those electrons filling that space the way you might think of the propellers of an airplane, where you could throw a ball between the propeller when it's stationary, but once the plane once you turn the plane on, then all you see is just, it looks like that propeller is filling the entire space. And if you then tried to throw a ball through the propellers, it would just bounce right back at you. This is our model for the atom.